So, analog devices and circuit, unit number 4, test and measurement devices. So, in this chapter, we are going to discuss about signal analyzer. Okay, so first we defined that signal generators. Now we are going for analyzer. So, why we go for analyzer? Okay, so analyze a signal. For example, if you measure some signal, we have to analyze whether it is properly get the data or it is more distorted, it is having noise, how to reduce the noise. Like we have to know about the spectrum analysis concept. We have different type of analyzers available: spectrum analyzer, vector signal analyzer, signal analyzer. That is definition of spectrum analyzer is the spectrum analyzers measure the magnitude of the input signal versus frequency within the full frequency range of the instrument. The primary use is to measure the power of the spectrum of known and unknown signal. A vector signal analyzer measures the magnitude and the phase of an input signal at a single frequency within the IF bandwidth of the instrument. The primary use is to make in channel measurements such as error vector, magnetic core domain power, and the spectral flatness of the known signal. The signal analyzer provides a function of spectrum analyzer and a vector signal analyzer. So this is the overview, that is frequency domain with the time domain. So time domain measurement is done by the oscilloscope. So frequency domain analyze frequency domain measurement will be spectrum analyzer. Okay, time domain and frequency domain. Okay, this is the difference between the oscilloscope and the spectrum analyzer. That is, oscilloscope are done by the time domain concept. So in spectrum analyzer, you define the frequency domain analyzing process. The way analyzer consists of a very narrow passband filter section which can be tuned to a particular frequency within the audio frequency range 20 Hz to 20 kHz. So this is the black diagram. So in this circuit we have input attenuator, drive amplifier, meter amplifier and a detector, then a filter amplifier, then meter range attenuator. That is R is varied for frequency control, C is varied for frequency multiplication. Spectrum analyzer type. The operation of the split frequency spectrum analyzer is based on the use of the super heterodyne principle, sweeping the frequency that is analyzed across the required band to produce a view of the signal, which is the relative state. So as well as we are using the fast Fourier transform analyzer. So this spectrum analyzer is a form of Fourier transform known as a fast Fourier transform. FFT convert the signals into a digital format for analyzing it digitally. These analyzers are obviously more expensive and more often specialized. Then real-time analyzers. So these test instruments are form of FFT analyzer. So one of the big issue within the initial FFT analyzer is type was that they look successive samples, but with the time gaps between the samples, this gave a rise to the some issues with the modulated signals or transients, as not all the different information would be captured. So requiring much larger buffers. Audio spectrum analysis, although not using any different basic technology, audio spectrum analyzer are often grouping differently to RF spectrum analysis. Audio spectrum analyzers are focused as the name indicates the audio frequencies, and this means that low frequency techniques can be adapted. So this makes possible to run these pieces with a relatively small amount of hardware, and sometimes even sound card made suffice for some less exacting applications.